All right, trig class, welcome to 6.3, Trigonometric Identities. So our big thing with identities is that we are trying to show that two different expressions can be equal. When you're doing that, a couple things to remember. You got to keep the sides separate. In other words, we're not solving the equation out. We're not going to be doing something to both sides. What we want to do is just work with one side to try and make it look like the other side. So the other side we'll just leave plain and we'll work through it and try and make it equal to the other side. So with identities, remember, because we're not solving the equation, we can't multiply both sides by the same thing. Okay, and that's the number one error and the misconception that most students have with trig is that in trig identities is they try and solve these out. And we're not trying, with identities, we're giving you a true statement in the sense that I'm telling you that 2 plus 3 is equal to 5. Okay, well, I don't want you just to move things around and tell me that 3 is equal to 5 minus 2. That is not what we're doing. What I need is for you guys to understand is we need to simplify and just work on one side of the equation. So let's look at some examples here. So I'm going to work through some of the even ones that you guys will do the odd ones tomorrow in class. But one of the first strategies when working with trig identities is to rewrite things in terms of sine and cosines and things simplify. So in number 10, we see that the cotangent of theta times the secant of theta. Well, again, we want to write them in terms of sine and cosine. So cotangent is cosine of theta over sine of theta. Secant is 1 over cosine of theta. Because these are straight multiplications, we can go ahead and simplify this. Cosine over cosine is 1, so that goes away. And we have 1 over sine of theta, which is equal to cosecant of theta. All right, so a lot of times a good strategy is just rewrite things in terms of sine of theta and cosine of theta. Another strategy is to multiply things by a unique form of 1. Okay, so when we multiply things by 1, that'll help us acquire common denominators, and it will also help us simplify things out. So a lot of times you have to be very strategical in the type of 1, but we always know it's 1 because you have something over itself, and anything over itself is equal to 1. So that's going to be another strategy as we work through these identities. So if we multiply these through, we got to make sure we remember to distribute. So if we have sine of theta over 1 plus cosine of theta times 1 minus cosine of theta over 1 minus cosine of theta, that things have to be distributed. So as we distribute these out, I get sine of theta minus cosine of theta times the sine of theta all over, well, 1 times 1, I'm going to get 1. So remembering to do these, minus cosine of theta. Then I have plus cosine of theta minus cosine squared of theta. All right. Well, what's nice about this is that this is a difference of squares. So this will simplify. The denominator, the middle terms cancel out, and I get 1 minus cosine squared theta all over sine of theta minus cosine theta sine of theta. Well, this should look familiar. that comes from our Pythagorean identity, that sine squared theta plus cosine squared theta is equal to 1. So if I subtract cosine over, I see that this is equal to sine squared theta. So I can simplify this. So I have sine of theta minus cosine of theta, sine of theta all over. Well, now this is equal to sine squared theta. Well, notice that each term involves a sine. So if I factor that out before, so I didn't need to distribute this out in the first place, but I have sine of 1 minus cosine of theta all over sine squared theta. So ones of the sines cancel out, and we're finally with 1 minus cosine of theta over sine of theta. All right, well, let's look at another one. So another idea is we want to be able to write things in common denominators and add them together. One thing that will get a lot of students here is just work with fractions. So we got to be good with our fractions here. So with adding fractions, we need a common denominator. So remember, to get a common denominator, we just multiply by a unique form of 1. So I need to multiply this by 1, and I need to multiply this by 1. Now, to be a common denominator, I look at the denominator over here, and I want it to be 1 plus cosine of theta. So it's going to be 1 plus cosine of theta, keeping that congruent. And then over here, I know I need to do 1 minus cosine of theta over 1 minus cosine of theta. Okay? So now, by doing so, I will start getting things that are a common denominator. These difference of squares are going to come up a lot, and we need to be good with them. So difference of squares, the denominator is going to be 1 minus cosine squared theta. The middle terms drop out, and the top 1 times all this is 1 plus cosine of theta. Over here, these difference of squares, so I get 1 minus cosine squared theta. Common denominator, what was my goal? And then on the numerator, I get 1 minus cosine of theta. Well, notice I can add these up, and I get 1 plus 1, and I get 2. Cosines drop out. Cosine of theta minus cosine of theta just goes to 0, and I have 2 over 1 minus cosine squared theta. And then again, this looks like my Pythagorean identity. So I know that this is 2 over sine squared theta. I've now added those. So another example here, when we're asked to simplify, remember to distribute things through. So I get my tangents. I'm going to get tangent squared theta. My middle terms, I'm going to get plus 2 tangent of theta. And my last term plus 1. And then I'm going to have minus secant squared theta all over tangent of theta. Well, here, again, I should see that I have lots of things in tangents, but I have this one kind of oddball out, minus secant squared theta. So I want to use my Pythagorean identities, and my Pythagorean identity, one of them states that tangent squared theta plus 1 is equal to secant squared theta. So if we do this substitution here, then I can get things in terms of numbers and tangents. So remember that it's minus secant, so everything has to be multiplied through by a negative sign. So I get tangent squared theta plus 2 tangent of theta plus 1 minus parenthesis tangent squared theta plus 1 all over tangent of theta. Well, this is going to be a plus 1 minus 1. 1 minus 1, that'll cancel out. And I have a tangent squared minus a tangent squared. Those will cancel out. And then I'm left with 2 tangent of theta over tangent of theta. Those will cancel out. And this is just equal to 2. And I've simplified that out. So another strategy when working with these identities is to factor things out. So when you factor this out, you'll see that we have difference of squares on the top. So I get cosine of theta minus 1 and cosine of theta plus 1 on the numerator. And on the denominator, they both have a cosine, so I can pull that out. Cosine of theta times cosine of theta minus 1. And then what I can see is that these two are identical. So then I see that this is cosine of theta plus 1 over cosine of theta. All right. So when working through these, we need to remember some of those strategies. So when we're establishing this identity, we need to make sure we understand we're only going to work from one side. We're going to leave the more simpler side by itself, and then you're going to work with the other side and try and simplify it so that it ends up being equal to the right side. So on this one, I'm going to work with our first strategy, write things in terms of sines and cosines. So I have sine of theta times 1 over sine of theta minus cosine squared of theta. Remember, I'm just working with this left side. Well, these simplify to 1, and I get 1 minus cosine squared theta. 1 minus cosine squared theta from my Pythagorean identity is sine squared theta. I see I've shown that this left side is equal to this right side. So I can just box this down and say that sine squared theta is equal to sine squared theta, showing it through my identity process. So let's look at our next one here. So when working through these, remember, these are some of the strategies we want to follow. We want to put everything in terms of sine and cosine, get a common denominator, remember your Pythagorean identities. Remember, only with squares. What we don't have is that sine of theta plus cosine of theta equals 1. It's not true. What we do have is that sine squared theta plus cosine squared theta is equal to 1. And so make sure you're always identifying that that only works with squares. Other strategy is to factor. And last one is just pray to the trig gods. A big part of this lesson, I think the big thing of this next couple of units is don't give up. You just got to persevere and keep trying different things. Sometimes what you try out the first time won't work out, and you're going to have to try a different strategy. And it's all about just persevering through problem solving. And so let's look at another one here. All right, so to establish this identity, I'm looking at trying to decide I'm working on one side. I'm going to pick the one that looks more complicated, the one that's not dealing with the sine and cosine. So I'm going to just work within this one. Remember, we're not solving this out. I want to establish that this is a true statement by following logical steps through our process. So in order to establish this identity, I'm going to see that first strategy, write things in terms of sine. So I get 1 plus 1 over cosine of theta all over 1 minus 1 over cosine of theta. All right, so now what I want to do is I want to try and, so I recognize that this term over here is 1. So what can I do to this to make this 1? Well, I can multiply it by cosine of theta. I can only multiply something by a form of 1, so I multiply it by cosine of theta over cosine of theta. So I remember I distribute. So as I distribute, I get cosine of theta plus cosine of theta over cosine of theta all over cosine of theta minus cosine of theta over cosine of theta. Well, the numerator is going to be cosine of theta plus 1 over cosine of theta minus 1. I got equal to the left side, so I have now established my identity. I box it and show that it's equal there. All right, let's try another one here. All right, for this one, what I want to do is identify, this looks a lot like my Pythagorean identity. My right side's more simpler, so I'm going to try and simplify my left side. So secant squared theta from my Pythagorean identity, that says that tangent squared theta plus 1 is equal to secant squared theta. We're going to use that and recognize that the numerator there can be written as tangent squared theta over secant squared theta. So now I'm going to use a strategy that everything's in terms of cosines and sines. So tangent is sine over cosine. So these were tangent was squared, so sine squared over cosine squared. All over secant squared is 1 over cosine squared theta. Well, I'm going to start working off my right, because this is equal to sine squared theta over cosine squared theta. Dividing by something is the same thing as multiplying by its reciprocal. So as I multiply by its reciprocal, the cosine squareds will cancel out, and I have that it's equal to sine squared theta. Box it, establishing my identity of that equality. All right, here we go on the last one. So again, the left side is going to look a little more complicated to me, so I'm going to work from the left side. One thing I notice is these difference of squares, and I'm going to want to try and get a common denominator when I'm subtracting things. So for both sides, I'm going to multiply by a form of 1, so that, and now when I say sides to both terms, I'm going to multiply by 1 to get a common denominator. So I'm going to have 1 plus sine of theta over 1 minus sine of theta. I'm going to multiply this by 1 plus sine of theta over 1 plus sine of theta. That's my 1. And it's going to be minus 1 minus sine of theta over 1 plus sine of theta. Now what type of 1 am I multiplying by? The other denominator, 1 minus sine of theta over 1 minus sine of theta. So the denominators I should recognize are difference of squares. So I know the common denominator is going to end up being 1 minus sine squared theta. The next ones I got to multiply out. So I'm going to do the left side here. I get 1 times 1 is 1 plus sine of theta plus another sine of theta. So I'm going to have 2 sine of theta. Sine times sine of theta is plus sine squared theta. So that's this numerator, right? And then I have a minus sign in here. And then I have this entire quantity that I got to multiply out here. So 1 times 1, right? 1 times 1 is 1. 1 times negative sine, so I'm going to get minus 2 sine of theta. Negative times a negative is positive sine squared theta. So that's what I have on that side. So I'm there. From here, I want to continue simplifying. So I don't like all this negative sign here, so I'm going to just write terms out. So I'm going to get 1 plus 2 sine of theta plus sine squared theta. Now distribute my negative through. Minus 1 plus 2 sine of theta minus sine squared theta all over. Well, this is my Pythagorean trig identity. I know 1 minus sine squared theta is cosine squared theta. So now that I have all those written out, I see that 1 minus 1 goes to 0. Plus 2 sine theta minus 2 sine theta, that goes to 0. So now what I'm left with is a 2 sine theta plus 2 sine theta, so I get 4 sine theta over cosine squared theta. Well, I'm getting really close here. I got that coefficient that I want. And I recognize, well, these are written in terms of sine and cosine. Let's go ahead and write them in terms of other ratios. So I can write this as 4 times sine of theta over cosine of theta times 1 over cosine of theta. Well, I get 4. Sine over cosine is tangent of theta. 1 over cosine is secant of theta. And I've now established my identity. This will take a lot of work and a lot of practice. You don't get good at identities by just watching these videos and knowing how to do it tomorrow, but it's going to take lots of practice and just experiencing these identities and learning some of the tricks and the strategies about going on these identities. I hope you enjoyed this video. I'll see you tomorrow in class.